Hello everyone. In today's video I'm gonna teach about how to simplify radicals a little bit more, and then talk about simplifying radical expression, and at the end I will talk about rationalizing the radical expressions. For simplifying the radical, I just want to use one more example. I want to simplify this radical 240 x y 7 x y to the power of 7 z to the power of 6 z to the power of 6. Remember that we have to continue the line of the radical, that everything be under the radical. I want to simplify this radical. The index is blank, so it means the index is 2. First of all, I have to factor this one to all of them to the perfect square and factor of the other things. For the 240, I want to factor to two numbers, one of them perfect square and the other number. How I can find the perfect square? Convert them to the prime factor. 240 converted to the prime factor by 2 is 120, by 2 is 60, by 2 is 30, by 2 is 15. 15 doesn't go to 2 anymore, by 3 is 5, and by 5 is 1. So by 2 is 120, by 2 is 60, 30, 15, 5 and 1. For 240, I can write it as 2 to the power of 4. 1, 2, 3, 4. 2 to the power of 4. Okay. Times 3 times 5. Times 3 times 5. Okay. This is a 240. I'm erasing this part. I'm going to repeat the other side in this part. So it's going to be 2 to the power of 4 times 3 times 5. X y to the power of 7. I can write it as y to the power of 6 times y. 6 plus 1 is 7. Why I'm writing y to the power of 6? Because 6 is the even number and I can divide it by 2, the index. And z6 is already, the exponent is even. Now, I can take out all the even exponents out of the radical by using this formula. X to the power of m, index of n, it's going to be x to the power of m over n. By using this formula, I'm going to take this one out. So the 2 to the power of 4 is going to be 2 to the power of 4 divided by 2, which the index is going to be 2 to the power of 2. This y to the power of 6, I can take it out, y to the power of 6 divided by 2, which is going to be y to the power of 3. This y remained under the radical, and this z to the power of 6 is going to be z to the power of 6 divided by 2, which is going to be z to the power of 3. So I take out this one, and this one. All the other things going to be remain under the radical. So it's going to be multiplied by 3 times 5 times x and y. Yeah? 3, 5, x and y. This part was the remaining part under the radical. And if I want to simplify, this is going to be 4 y cubed z cubed square root of 3 times 5 is 15 x y. So this is the simplified format of this one. Okay, let me erase this part too. So 4 y to the power of 3 z to the power of 3 radical 15xy is the simplified format of the top one. Okay, this is one example about simplifying the radical. Let me just do one more example. Okay, one more example in the simplification of the radical, then I'm gonna go to the next step. Okay, let me erase this one. Okay. Let's say for this one. Is C3 c to the power of 3 e to the power of 5 over 44. Okay, this is the question number 34 of your book, page 350. I want to simplify this one. Again, separate the even exponent, that because the index of the radical is blank, all the even exponents are divisible by 2, so we can take them out of the radical. What's going to be for this one? This one c to the power of 3, I can write it c to the power of 2 times c. Yes, c to the power of 2 times c is c to the power of 3. E to the power of 5, I can write it e to the power of 4 times e. Okay. What about the 44? 44, I can write it as 4 times 11. Again, if you don't find this one, just convert them to the prime factor, you will find it. Now, I can take this c to the power of 2 out of the radical, sorry. I can take this c to the power of 2 out of the radical, I make it c. E to the power of 2 out of the radical and make it e to the power of 2, e to the power of 4. If I bring it out of the radical, it's 4 divided by 2, e to the power of 2. What is remaining under the radical? CE. And what about the denominator? I can take this 4 out of the radical 11. Okay? Or, remember, I can write it as CE to the power of 2 divided by 2 radical CE over 11. Both are the same thing. This is other way of simplifying the radicals. Now, I just wanted to explain you this formula. Radical x over y. We can write it as radical x over radical y. Okay? Radical x over y, we can write it radical x over radical y. And radical x y, we can write it as radical x times radical y. Okay? Radical x times y, we can write it as radical x times radical y. And radical x over y, all of them under the radical, we can write it as radical x over radical y. These are the formula that you need to remember. I use this formula to solve this one. Okay, this is the right answer, and this is the right answer too. But remember, we cannot keep the radical sign in the denominator. We have to remove the radical sign from the denominator. That's we call it rationalizing the radical expression. That I'm gonna teach you in the next level. I'm gonna teach you in the next video. Okay, so it's fine for now. I'm gonna create another video and submit it to you. Bye for now.